Hello guys, another problem of moment of inertia, and this time I'm gonna do this problem by following two different methods. Not two different methods, it's the same method actually, but two different ways of approach the same problem. Okay, so let's start now. This is the problem. We have to determine the moment of inertia with respect to the x and y axis for this shaded figure here. All the units are in centimeters. So this particular problem, I don't have to calculate the centroid of the shape because the problem is asking me only with respect to the x and y axis. If the problem asks you with respect to the centroid, remember first locate the centroid and then apply the same method that we learned before. Now we can also calculate it with respect to x and y and then transport it to the centroid of the composite figure if we want to, but this is not the case. So when it's not with respect to the centroid, the whole process simplifies a lot, if you will, because there's less calculation that we have to perform. So we're going to build a table, and in the table is going to be just figure, and then moment of inertia with respect to x centroidal for each one of the figures, moment of inertia with respect to y, and then you have the area, and then you have x, y. This is the weekly x or y, and then 8 times x squared and 8 times y squared. That's basically the table that we have to fill. And once again, this is just a reminder, but for you, but once we learn how to do this, we are not going to be doing it, so detailed. Figure. Well, the first thing is the compositing figures. I did the first division like that. I'm going to say this is figure 1, I'm going to say this is figure 2, and I'm going to say this is figure 3. I like all the time to put my axis of reference here, whatever the figure 1 is referred to, and put my figure wherever it goes, because in that way it's like a graphical cue of what I have to do. Moment of inertia with respect to the triangle, you should know it by memory right now, but when you have a triangular area, moment of inertia is 136 BH cubed. So this is BH cubed divided by 36. Remember to put the units, centimeters to the fourth for moment of inertia, centimeter square. In that way you don't have to repeat it every time. Centimeter here, and this is centimeter to the fourth also, and centimeters to the fourth. Okay, so BH cubed divided by 36. For this figure, B is 6 and H is 3, so 6 times 3 to the third divided by 36, which is 4.5. Now I sub 0 y, if this is BH cubed divided by 36, then with respect to y, it's going to be HB cubed divided by 36. That's going to be 3 times 3 times 6 to the third divided by 36, and that's 18. Area, 6 times 3 divided by 2, please remember divide by 2, because it's a triangle. X, okay, X, what is X? X is the distance between the centroid, in this case of figure 1, which is located here, and our axis of reference measured in the X direction. So that means that for that figure, my X should be between this axis and that centroid. How much is that? Well, by now you should know by memory also that the centroid of the triangle is located 2/3 from the base, from the acute angle. 2/3 from the base, and the base is 6, meaning this distance is going to be 4. Now, what is y? Y is the distance between the centroid of figure 1 in this case and the distance from here to here, which is the axis that we are considering. What is this distance? This distance is going to be 6 plus, and with respect to this right angle, I know it's going to be 1/3 of the height, and the height is 3, so it's going to be 6 plus 1/3 of 3. 1/3 of 3, which is this little piece here, plus 6, that's 7. Then 8 times x squared is going to be 9 times 4 squared is 16. 9 times 16 is 144. And 9 times 7 squared, which is 49, this is 441. Done, figure 1. That's super easy, easy peasy lemon squeezy. Now let's go to figure 2. Figure 2 is this one. If you don't know what easy peasy lemon squeezy means, you can Google it. That was an old advertisement from US. So now, this is the figure 2. Well, BHQ divided by 36. Now what is B? B is this distance. What is that? 6. Now what is the H? H is the total distance from here to here. How much is that? 6 plus 3, 9 centimeters. So it's going to be 6 times 9 to the third, 6 times 9 to the third, divided by 36. 6 times 9 to the third, 6 times 9 to the third, divided by 36. And this is equal to 121.5. And in this case, it's going to be H, which is 9 times 6 to the third, divided by 36, which is 54. What is the area? Area is 9 times 6 divided by 2, or 6 times 9 divided by 2, which is the same thing. 54 divided by 2 is 27. And then x, what is x? Well, x is the distance, measuring x, of course, between the centroid of the figure 2 and my axis. What is that distance? Well, that distance is going to be 6 plus, and from here is 1/3 of the base, 1/3 of this distance. That means 1/3 of 6, which is 2 plus 6, 8. Now in y is the distance from here, from my axis, to this point, which is from here to here. This is 9, right? From this angle is going to be 2/3 of 9. 2/3 of the height. That's 4 centimeters. 2/3 of 9. 18 by 3, 6. I say 2 times 9, 12. And so, done. Okay, so 2 times 9 is 18. 18 divided by 3 is 6. Now 8. And you know that type of things happen to you in the exams because you do it in your mind instead of using the calculator, or use the calculator. Now we have area, which is 27 times x squared, 64. 64 times 27, I have that as 1728. And 27 times 6 squared, this is the one that goes here, I have that as 972. One more figure and we are done. What is the last figure? The last but not least, figure 3, is this rectangle here, this rectangle of 6 times 6. BH cubed divided by 12. Why by 12? Because that's what we have for a rectangular area, which is this one. Moment of inertia with respect to the centroid xy is 112 BH cubed. Or B is 6 times H is 6 divided by 12, and that's equal to 108. For the y direction is HB cubed divided by 12, but it's the same because 6 times 6 to the third divided by 12, 108 also is a square. It's not a rectangle. Has the same moment of inertia in both directions. Now area is 6 times 6 because it's 6 times 6, 36. X, what is x? X is the distance measured in x from my axis to the centroid. What is that? Well, if this is the center of this rectangle, this square has to be exactly at the center. This is 6, this is going to be 3. And in y is also this distance, which is going to be also at the center of the squared. So this is gonna be 3, this is gonna be 3, so this is gonna be 36 times 3 squared, which is 9, that's 324, and same thing for this one, 324. Now remember the formula for Steiner theorem or parallel axis theorem. I sub x equal the summation of all the I sub 0 x, I sub 0 or I naught x, plus the summation of all the a's sub i's times the distance in y squared. And for y is going to be the summation of all the I sub 0 y plus the summation of all the I times that distance squared. So that means that if I get this I sub 0 x with this summation here, I'm going to do that summation, I'm going to do this summation, these two will give me this, and then when I do this summation and I do this summation, that will give me that. So let's do that. When I add all of these here, this is going to be 234. This is 108 plus 54 plus 18. That's 180. Units are here. 1728 plus 144 plus 324. 2196. And then 441 plus 972 plus 324. This is 1737. I sub x then is gonna be this plus this. I sub 0x plus summation of ay squared, which is 1737 plus 234. I sub x is equal to 1971 centimeters to the fourth. What is going to be I sub y? I sub y is the summation of I sub 0 y. So this and this, remember, is I sub 0 x. Now I sub x. Now this and this is 2, which is 180 plus 2196 is I sub y, and that's 2376 centimeters to the fourth. There you go. That's a really nice example, good example. In this case, we consider these three shapes and we calculated Ix and Iy using the parallel axis theorem. See you in the next videos, guys. Keep watching.